So here's the issue that's being mentioned. So what is this price? This price is the reservation price of this seller. Just that, like, this momentum will be the momentum of this mass. It's not somebody else's momentum. All right? The fact that it's positive means that the velocity is positive. That means the sales volume is positive. That means that it's relative to the market, and this is the market, it's a seller. All right? I could have drawn it like this, and then the price would be this way because P is N times V, and then it will be a buyer relative to the market. But I did it. All right? And the whole thing will be reversed, but it doesn't matter because it's all the same. Right? Now, one way, we're going to get to kinetic energy, but now let's just do this intuitively. Suppose this thing has a certain kinetic energy, right? So we all know that it's a half P squared divided by N, right?
Kinetic energy relative to market.
Yes. Now, what about this P? This is relative to the market, right? Why? Because the principle of relativity tells us that, right? P is N times V. V is relative, right? So if this P is going to 0, that means that it's not selling anymore. The sales are 0, right? The kinetic energy will disappear, right? Okay. But now suppose I have another guy over here that's going this way, right? This is a big mass. The only way I do it so big is because I don't want this guy to change its momentum, you know? So it's just a momentum sink, you know? It's like a price sink. You could like dump all this money in there. It's not going to move very much, all right? That's what you think of as a market, okay? And all of a sudden, if it trades with this guy, then the kinetic energy, then this one has got, this one is a buyer, right? So these are his purchases compared to the market. But if they kind of don't trade with the market, they trade with each other, and you take the perspective of one of them, you will see that he has way more kinetic energy, all right? Because now the difference in velocity is much higher, and the surplus will be much bigger, because this one is a net buyer, and this one is a net seller, right?
And then you add both surpluses?
Yeah, you have a much bigger surplus between these two individuals. Huh? You have a much bigger surplus than between this one and the market. See, the market is your inertial reference frame. That's what you choose, right? And the way I set it up is that there is a friction force here, and that friction force is exactly the handling fee, all right? And the way I did it like this, I can keep that force constant, okay? So I can have a constant handling fee. I could have had a situation like this, and then the handling fee would change with the throughput, the amount of sales, right? So all of a sudden, you know, we'll have something like that rather than this constant fee. And it will just complicate the whole discussion because I haven't introduced dampers yet and all of that. But in principle, it's all the same, all right? I just want to have this constant handling fee. And the reason I did it is because that's how Adam Smith does it. He says, well, how do I determine the price? How do I determine these DPs? Well, I can look at gold, but that sucks because gold is in demand and then it's not in demand. So gold is some kind of mass, and he was writing after the discovery of America, and then this mass would start changing with velocity because the supply of gold and silver, it was silver actually, went up huge. So all of a sudden, you know, now you got this all the surplus coming out of nowhere, you know, if you're using that as your inertial reference frame. But who cares about silver? You cared about pins and needles and all these other things, you know. So people realize that it's just not a great inertial reference frame. The silver that used to be constant up till the discovery of America, the supply of silver was constant. So silver was always going at the same speed. And then the discovery of America, all of a sudden, they get jerked around. So they have to find another inertial reference frame, all right? So Adam Smith says, well, you got to use labor, right? So that's why I chose this handling fee, right? And Joule later said, okay, well, you know, we'll use a weight in the gravity field. Well, gravity is also not constant, but you know, they're always looking around for something that has a constant force, right? So that's why I chose this handling fee, because that's what Adam Smith suggested. I just kind of modernized it. All right? But here again, I mean, all that's going to happen is if you look at this physical situation, if it has a velocity like this, a momentum, but you know, this velocity is with respect to this one, at a certain point it will just stop. It won't go the other way, right? You know, that's it. And the same thing will happen here. It will just stop, you know? You just depreciate the value of. It's called, accountants call it linear depreciation, although mostly that's about capital. But let's assume this is some inventory capital, and boom, it goes down, and then it's done. The stuff is worthless. Well, how is it worthless? Well, it's worth something. If you trade it with this guy, maybe worth something, but with respect to the market, it's worthless. The market is not going to give you anything for it. Huh? So the market price is, you know, it's zero, right? The market value. Huh? But the personal value of somebody else maybe, oh, yeah, no, I'm looking for this, and I'm precluded from being on the market, so you buy it on the black market, you know, you start going with each other, all right? Okay?
Okay, and we can go a little bit further on this handling fee, because I think I misunderstand that part. Because if I'm producing apples for a cent per apple, here, but producing it for a cent per apple, and the market says I want to buy it for a euro. So 99 cents is my reservation price below that of the market. I can now sell it with 10 apples a day. I would say 10 apples times 99 cents a day would be my surplus. If I now add a handling fee for of 19 cents, this wouldn't reduce 19 cents per apple. This wouldn't reduce it back to zero, right?
All right, so I'm not sure I can follow this, but what I do know is that I want to talk about this thing in the next slide. So let's do that, and then let's see if you can repose your question in the context of that, okay? Huh? So you want to go back to this graph, right? So all we did here was this typical diagram we make, you know, in engineering, you know, a bunch of forces, and then we just calculate the work, and we calculate the kinetic energy. This is how you have to view this effort here, right? Huh? What I just did. And what I wanted to show you is that this goes through okay, huh? And we get conservation of energy and la, 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 all right? Huh? So we realize our wants, and by that we can, you know, book a gain or a loss, right? Depending on whether we credit or debit. So let me move on. And then I believe this is the picture that you're referring to, okay? Right? So let's just figure out what's going on here. So here is where I'm going to say, all right, I know what a gain is. Gain is this, right? So in the negative of that, this is a gain. Huh? And so my sales amount or my demand, you know, my purchases is this, and per unit, I'm doing a price change, the price goes up with this amount. Or if I do a minus sign, it goes down, then it becomes a loss, all right? So that's just a gain that I made, all right? An incremental gain, right? This thing is sometimes called the price margin, huh? Or just the margin, huh? Okay? So you multiply your output or whatever it is, your sales by the price margin, and that's the gain you're making as a unit of time, right? Per whatever, huh? Okay? Fine, you say. Okay? Now I can have this idea like, well, okay, I'm changing my quantity demanded, all right, or supplied all the time. As the price goes up, I'm going to supply more. So I can make another gain on that, and another one, and another one. Why? Because my supply is a function of time, of momentum, right, of a price. Which function? Well, it's precisely P divided by, well, why did this thing pop up? Right? Actually, this thing has a name, and this is called the Marshallian demand function.
Supply.
Yeah, it's called in the literature demand, but this would be the demand function. You're right. Huh? Okay, thank you. That's right.
And then this demand is relative to a previous demand. So this would have these change in demand as a function of change in price.
Now this is just a function. This thing just relates the quantity demanded to the price. Okay? Right? And you can see that if the price is zero, then the quantity is zero. That's just obvious from the way this function is written, right? It's linear. Now, in real life, this doesn't go this way. I mean, you'll have some number here, right? Huh? But you remember what we need to do. We need to like bring everything down, that when the velocities are, relative velocities are zero, the momentum is zero. So when the relative demand or supply to the market is zero, then we'll take the price to be zero, right? Huh? So we'll say the individual's reservation price is zero when he is in equilibrium with the market, all right? He's going at the same speed, all right? Okay? That's just our definition of zero price. So don't, in your mind, don't start adding stuff to this, all right? It's not a price that you can just get off the shelf, you know? Huh? Okay? Remember, huh? We've been talking about this a lot of times. That's the way we need to calibrate it, all right? So it's relative, all right? Momentum is relative. Kinetic energy is also relative. Right? And we need a linear theory. If I add this number here, I don't get a linear theory, right? I can't use matrices. I can't use anything. You know, it sucks. I don't want to do it. Huh? Then I can't do economic engineering. So, huh?
That's okay. I understand you can linearize around the point. So okay, that is nice.
Well, this is not really linearizing around the point. You could still linearize the point and add a constant, and it will be an affine transformation, all right? Huh? What I want to say is that the zero is a zero. I'm just choosing a zero, being the market, okay? All right?
And but it is market price, that is zero, but zero transactions, zero velocity.
Yeah, but I want you to be really clear about what you mean when you say the market price is zero. Whose price are you talking about? You're talking about the price of this guy, okay, this individual. And he says that his relative price is zero if he is in equilibrium with the market, okay? Now, what the market thinks about itself, how it relates itself to other people, I don't know. I don't care about, all right? Huh? Right?
So if everybody says this price zero, they are at market price. And what is the velocity corresponding? Also zero.
Yeah, so that means he's neither supplying nor demanding from the market. He's neither a buyer nor a seller, right? Okay?
Okay.
Yeah? So if his velocity is positive, we'll say he's a net supplier. And if his velocity is negative, his quantity, we say he's a net demander. All right? Huh? Okay. So, oh, by the way, here it is. So the demander I've done in red. These are negative numbers, right? So this is one guy. Here he's a net demander, and here he's a net supplier in blue. All right? When he is a net supplier, he has a positive price. Okay? And if he's a net demander, he will have a negative price. Okay?
Yeah, okay.
All right, if he's a net supplier and he wants to become an equilibrium market, the price has to go down. So P dot has to be minus the force, right? That's acting on it. That's what we just saw, right? So the previous slide, you see this thing, this is the positive direction of the price. So he's a net supplier. He's supplying to the market, but he's paying the handling fee. This thing is reducing this price, right? At a rate of P dot that is minus, here it is. So this rate, okay? Right? So we have F plus P dot is 0, right? Okay? If I look at this thing, this seller here, the handling fees plus the price change, his movement is 0. If the handling fee is positive, then the price movement has to be negative, right? So the total price is what the buyer gets plus the handling fee, all right? This is the law of conservation of momentum, or credit is debit, right? Huh? All right? No, it's not right.
This handling fee, is this money per item, money per second, money over the total profit?
No. Almost the same. Right? The units of force. Come on. Eh? So you pay a handling fee per item per moment of time, you know? So you hire these people, you got to pay them per time, and they can handle so many of these things, okay? That's the handling fee, all right? The price change, what is the price? Well, it's this, and then you have to look at a change in time. It's also this, okay?
Okay, but a real life example of a handling guy.
Administratiekosten.
Administratiekosten. Okay? That's called a handling fee. So usually, if you look it up, and I actually bothered to look it up, a handling fee, and there are some sites, some business sites, and they'll tell you how to calculate a handling fee. And it's an extremely simple formula, and it says, well, you look at how many jobs you do, how many lots you sell, and then you calculate how much time you do it, and then you look at the amount of cost, and you divide the cost in dollars over the lots and the time it took you. And that is a handling fee, all right? If you look it up, you'll see it, all right? Okay? So 2 handlers can do twice as much. Like 2 horses can pull twice as much, okay? That's why that guy in his mill had 2 or 3 horses, all right? They can't go necessarily twice as fast, right? Okay? You know, that's it, all right? But if you need 2 handlers, you know, they'll both be handling at the same rate. Okay, that's fine, right? But you'll be paying twice as much, okay? Right? Okay? Now, how does the seller pay this handler fee, an handling fee? he has to reduce it from the price. He has no other way. Otherwise, he has to make a separate payment. Okay? But the way I set it up, there are no other forces. So all that he can do is to say, well, the total price consists out of this and this and this, plus so much, in handling, right? Huh? Okay?
So I should more look at this personal price as profit per item instead of a price.
A profit is when you multiply by the amount. That's not the want. This is just what you desire to do. Then I can multiply by the amount sold, and then I can start calculating the profit, okay? And that's what I'm doing here. That's what I'm doing here. But don't look at this force as a profit, okay? Huh? The profit is a difference of two prices, okay? You know, there was another famous example where you have to see that these handling fees are something real. So in the, I think we talked about this before, what price is. So you can, in the 60s, they had an energy crisis and they had price control. So you went to the gas pump and they said, well, you can buy a gallon for $1, but you can only buy so much, okay? Now, what happened was you can say, well, this is just a price control, so you can control the price. But that's not really what happened. What happened was guys started paying other people to go stand in line for them, right, over time, okay? And what was the wait time? That was precisely the cost per tank of gas per unit of time, if you integrate it over time, right? That would make the black market price equal to the official price. You understand? Huh? So you had the black market, the official price, plus the integral of this wait time, dt, right? Okay, that's the handling, that's the service you deliver, all right? Huh? And that's the real price, that's the real reservation price, okay? Huh? Or the black market price. So this is a force because somebody has to stand in line, for so much time, all right? And by this, you know exactly, if you integrate this out, and then you get that this is the black market price, and this is the white market price, huh? Then you can exactly know what the wait time is, all right? Okay? That's the handling fee, that's the waiting fee, whatever you call it, transportation fee. It's just a fee that comes on top of the price to get the real reservation price. What good are all these things he's selling if he can't get them to the market, right? So the farmer's got his pig, he's got to bring him to the market, but he's got to add the cost of using the Roman road and the tolls and all this stuff to the price. It's got to subtract from the price. What else does he have to pay the toll? Okay? So you saw in that other thing, last week we discussed about how these Roman roads created these markets and everything. And what you do is you bring the handling fees down, right? So there's less friction, okay? And that's exactly what I want to show you here. There is less friction, right? This is a friction force. That's how I rigged it up. Now, suppose you have pigs in Bologna and you want to deliver them in Delft. That Roman road is going to cost you so much in tolls that the price drops to zero and you might as well stop selling, all right? Huh? Okay? But if you have a cheap airplane, then you can bring this friction down and then, the price discount becomes less, all right? Yeah.
I get the feeling when you say the price becomes zero, you mean actually price margin or
the premium.
Yeah, okay, because price and premium they're not really the same thing, is it? I mean,
well, they are. I mean, momentum is, you know, what you have to understand. If I keep saying premium, it's just confusing. You know.
Less confusing than all these prices.
What?
Premium, that makes immediately a click.
yeah.
But if you say it's also a premium, then that makes a fit, at least for me, with what you just told us.
Okay, I'll tell you why I don't do it, because there are several reasons. Why is that first, economists don't do it, right? They just call it a price, right? Okay. Number two, a premium usually is something else. It's in percentage, you know. Oops. Percentage per time, huh? And maybe per unit or something. So an insurance premium, right? What? Risk premium. Okay.
What we're talking about here is transfer prices.
Yeah, it's transfer prices, you know.
But I do get the.
Yeah. So the thing is, and a discount, like if I read Marshall, he may use discount in this sense, that you're actually discounting the price, okay? But we don't use discount this way. It's always a percentage, okay? Right? So here's what you do. So for instance, you have a damper now. Let's just go ahead, right, for one moment, right? Jump ahead with this thing. So I don't have a constant handling fee. Now my handling fee depends on my output, right, or my sales, okay? And there's a constant of proportionality. So now I have just a damper here, okay? Think this, you know, eliminate this from your mind. Are you, Then what I could do is I could say this is equal to B, and what is this V? Well, that's P divided by M, right? Okay, because I'm looking at this mass here, all right? And that is equal to B divided by M times P, right? And this thing is sometimes called the premium rate, right? Because what's the units of this? You get, if you rewrite this as F is B divided by, I'm going to call it gamma times P, you will see that the units of this thing is 1 over time, right? Okay. So you'll see that what this thing does, this damper, it discounts this. This is sort of a price discounting mechanism where you go as a percentage. This tells you the percentage of loss of price you have over time, okay? If you look at a damper. And this is then called the premium, in this context, okay? So it's just, that's the reason I don't do it. Now, the other thing people say is if you look at these, what you see, what you also see is that this is called the price spread. So you could have a bid here. What is it? The buyer. So this is the seller. So this is the ask, and this will be the bid, right? Huh? Okay. Then you can, this difference is usually called the spread. Huh? Then they may say, okay, the true price is here, right? And then if you divide, and if the spread is symmetric, then they say half the spread, then this thing would be half times the spread. Huh? You see this a lot on the stock market. You know, if you look at NASDAQ level 2 or something, you'll see these guys bidding and asking, and then they'll let the zero, the zero will be where the current market price is, and then you'll see the bid-ask spread around it, okay? So then they don't say premium, they'll say the spread is so much, okay? So many different ways that is used, and ultimately I have to choose. For commodities, this is just, when you say the price over market, right? Okay, that's the thing. If I say premium, then you'll be okay now, and then in a little while you'll be confused again because it just gets used in a different way, All right? Huh?
But especially in the on the stock market, the spread is just not a static thing as it cannot change, but there are 5 sellers for €1 above, and 10 sellers for €20 above. But once you have bought those stocks they are selling, they're gone.
Yeah, but this is aggregate demand. And we talked about this last time. Remember how you can have a center of mass motion? So there could be lots of little buyers and sellers, and together they make up this demand line, okay? And then you can count how many are going at this velocity and at that velocity. But this is a topic I don't want to deal with now, you see? Just want to talk about the pure phenomenon. So suppose it's one seller and then, or one kind of unit, rather than talking about what's going on inside there, Huh? So if you have a mass, of course, it's not one thing. It's all kinds of atoms moving around. And when you start pushing, you're pushing against one of them, and there's some forces holding it together. Say it's a balloon, you're going to be, these things will push against others, and it gets complicated, right? All right? Huh? Okay? So what the exercise here is to distill some essential feature and not burden ourselves with all the minutiae of what's really going on. And that's what you do in mechanics anyway. You don't worry about the quantum effects or the molecular effects. You just kind of get an essential center of mass motion here, all right? Huh? Okay? So try to abstract away, all right? And just see that if there's a demand line, then, and then these are different ways you can do it. You can call this price, but they also have interest rate spreads, and look, it gets confusing, So, and price is just the thing they use, And it's the thing. Of course, I can make it all cool, But if I do that, then I can also say, well, why does mechanics just talk about the momentum of something or the kinetic energy? You're right. It's confusing because if I'm standing still, I have no kinetic energy, I have no momentum with regard to you, right? Okay, right. But I have an enormous amount of momentum compared to somebody who's flying by on an airplane, right? They're looking at me. Huh? Okay? So all of a sudden, my momentum came from nowhere. Why? Because somebody else was looking at me, who sees me flying underneath him on his airplane. Huh? Okay? So should I, every time I use the word momentum, say it's really the momentum premium over? Huh? You see? Huh? So if you demand purity, you kind of get yourself in a never-ending cycle of becoming a mathematician and just, huh? And then you can junk most of mechanics, because what happens to your kinetic energy? They will also increase. So every time I say, I cannot say anymore this mass is this kinetic energy. No. And with respect to the, you never do that, right? So what you got to realize is that it's understood that there is an inertial reference frame out there from which we're doing all the calculations. Okay? Right? So if you see a mass and you imagine this force, I mean, what the hell? Does this force come out of nowhere? Well, the way we draw it, you would think so. But then you can say, well, why in electrical engineering, when it's a coil, right, it has 2 terminals, and this thing only 1 terminal, right? And if this is the voltage, I can measure the voltage, but I have to do it across, right? So these guys do a good job, but I'm doing a terrible job here. This is like, But if I have a spring, no problem, right? Then I have a force and it goes right through. But where is this going through? Huh? No, it's going through here. Here's the, Okay? So the other terminal is the Earth. Huh? Okay? But it's understood. And so it is in the economic engineering analog. It is understood, all right? Because this is an analog. So it will suffer from the same unclarities of the mechanical system. You understand? Huh? If I were to do this all in electronics, I wouldn't have the problem. I would just have a price drop over an inductor. You know, boom, problem solved, right? Okay, but I don't. I have a mechanical analog, right? Okay? So you just got to keep your wits about you and realize that force, momentum, kinetic energy, all of it does not exist without the existence of an inertial reference frame. Similarly, the wants, desires, prices, surplus, they do not exist without a reference to a market out there that is establishing a point of zero for everything, right? Huh? Okay? All right. I mean, this is, it seems like we're wasting time, and we really aren't, because these things, they kind of, the problem with this is you can do all this stuff without really knowing this, and you start calculating, and it will work all right, and then you get stuck, and then all of a sudden you will never be able to extricate yourself anymore.
Yeah, I think the only.
Yeah, they handle this correctly? It's the toughest course. Huh?
Yeah.
Yeah. It's the toughest course.
Yeah.
Huh?
Yeah.
What course was what? I didn't quite get it.
Schriftelijk rapporteren.
Now, she says that the only course that does it correctly is the advanced dynamics course, and that's at the same time the toughest course, okay? So it's just a problem, you know? But this problem is not just economic engineering, and I don't want to just fix it for economic engineering, you know? I just want to make the analog to what you know and what you've been taught, all right? Huh? Okay? But well, the thing is, like, we started this lecture and we're saying, like, you know, okay, what is kinetic energy? And you guys got it, you know, the half of you got it wrong, right? So it's just hard, you know, you can stand here and you think you're quite an engineer, and then you don't even know what kinetic energy is, and a few weeks ago you didn't even know what Newton's third law said, you know, and you still don't really get it right, and you know, huh? So this is just an area where you have to have some degree of modesty in order to, huh?
Quite the master of science.
Yeah, yeah. So you can, yeah, you can sometimes wonder what you really mastered when you got that Master of Science degree, huh? So, but you know, there's no reason to be depressed about it, because it's, I mean, it's just hard, okay? It's just hard. It's just hard. Mechanics is hard. Engineering is just hard, you know? Anyway. But now let's look at it, huh? So we can actually graph this stuff, right? So this is a gain. So you do a price margin and you multiply it by your sales amount. And what is the, so we say actually, this is the, at this margin, at V, so dP is the price change margin at sales volume V, right? Okay, will give me a gain of dP, you know, over this amount, okay? Huh? So this is an incremental gain measured in per time. Huh? All right? So suppose I am over here, you know, I'm demanding this from the market, right? I can start selling to the market, right? And then every time I, well, this is, you know, every time I sell, I drop my demand a little bit, I drop my demand a little bit, and when I do so, I add all these up, right, all my gains up, from P to 0, or from 0 to P, wherever you want to go, and then I get what is called the total surplus, okay? So you remember the first slide, when you see that Wikipedia thing, that's the total surplus, okay? And that's just what it is. At the same time, this is the kinetic energy. You all know that, right? It's a half P squared divided by M. All right?
Do you drop your... That's like,
well, I'm just going, I can go the other way. I should go from, this is 0, right? And this is minus P. So let's go the other way. Let's go this way. Huh?
I think the question triangle. Get why it is.
We'll get to that. We'll get to this. But here's what I'm doing. Here's P. Here's 0. Right? Then you would agree with me that this area is this. Okay? So it's the area above the demand line. Right? In fact, you would agree with me that this will be at price P. I change my quantity demand with V. Right? So this is what I have to pay, right? And this is my increased extension of demand, right? So this is a marginal cost, cost increase. Okay? And this whole area here would be the cost. Let's go to the next slide to make this totally clear. So you're asking, why don't I just calculate this area, right? Well, now I'm a seller. My reservation price is this over market, which is 0, right? So the total value of what I have, right, would be the price times, this is the total value, Okay? But what is it worth to me? Well, it's not worth that much, right? You know, that's just what I can get to it if I were able to sell this all for this price, okay? I mean, I have all these handling costs, all this other crap I have to deal with, but if I were able to sell this, as the total thing I would get, right? But what is the value that I'm really receiving? Well, that's the price, right? Times value to me, okay? Because as I decrease the supply, this is getting worth less to me, right? Or if I increase demand, it's getting worth more to me.
Why are you deep?
Well, you know, the price at every level of demand quantity, this is the price. That's the value to you, okay? So, but here the value to me is higher. So if I add this, then I get the total value accruing to me over time, right? This is also called the value in use, or the cost. That's just what it's worth, right? To me.
What I'm imagining is that I'm in a market and I'm selling a certain flow speed at a certain price. Why would I ever drop that flow speed that the price drops and I get this triangle shape? Why not just sell at that price?
You could, and if you do, what would you make? You would make this, right? And you would make this much of the true value to you, right? And this will be extra money you just get, right? Yeah, you can call this the revenue. This will be the total revenue.
So the surplus is the revenue.
But that's assuming you can sell it. You can sell it at this rate, right? But you can also call it the market value. So if the market were willing to pay you P for this thing, right? Then if you were able to sell it, then this will be the total value, the market value, right? So if you do, you mark something, it's called marking to market, right? So you mark this, you have all your stuff, and you mark it to market, right? So there's this old joke of this guy, and he found this great stock, and nobody's buying it, and he bought some. You know, he tells his broker, go buy the stock of this company, right? And he looks at the following day in the newspaper. That was at the time he didn't have the internet yet. And he says, well, the price went up, right? So, yeah. So he bought it, and the price went up, right? So then he says, oh, this is going well, right? So he says, I market to market. I have this whole area now. So he's buying, right? So he's going like this. Huh? And then he buys some more, and then the price goes up even more. And then he buys some more, and he goes up even more, right? Okay? So this is all the value that he sees in this, wow. Huh? There's not what he paid for it, most likely. What he paid for it is this, right? Huh? Okay, that's the cost. But this is what it's worth, right? So this is the cost. This is what the whole thing is, what it's worth. Then he tells his broker, okay, sell the whole thing. And then the broker says to who, right? So he's obviously not doing, he thinks the market is there, but it's all disappeared. He doesn't have a market. He doesn't have an inertial reference frame that he can push himself off against, and he can sell it to nobody. And in fact, it's all gone. But if he finds another sucker, now, and the guy who bought it from will buy it back, then he can just make this amount back again, right? Because that's the real value to everybody, right? But if he marks it to market, then he will get this, right? Okay, that's called marking to market. Mark to market. So you got your portfolio. You can look at the securities at cost. That's how much you paid for it, right? That's what it was worth to you at that moment. And then you can look at it market value. That's using the last price, so the biggest price, okay? And then you can say, well, I'm going to book a profit of this much, which is that difference, okay? So indeed, that profit is VDP, right? This integral. Those are all the gains he made. On every trade, he made a little gain, all right? Only this book, right?
Then you should use Q, right? Not the V.
No. It's the sales. So we're at the market. This is the volume. No Q's yet. That comes later when we do analytical mechanics, okay? Right? Huh?
X is also okay for me. If you just want to use the Q, but if you say I bought so many, then I have so many, and the market price at this moment is this many.
No. This is not a Q. This is a V. All right? This is the volume. This is you're continuously selling at this price. Okay? You have this business and you're selling apples at this price, okay? Or oil at this price, okay? Don't forget that. The demand curve is about the quantity demanded. It's a flow, all right?
Okay.
Okay?
I'm set at this way, and then the price goes up. Then I didn't make a profit, right? If anything, I made a loss for all the apples that I sold yesterday, and the day before, and the day before, at a lower price, then I can sell them now.
I mean, it's going to take me some time to parse through what you're exactly saying, but let's do that a little bit later. Let's conclude. I feel you're almost reading more into it than there is. It's just you're just creeping up your supply curve or your demand curve, and you're just keeping track about what it's worth to you, right? So here you see, what is the price here? That's the marginal. If this is the cost, and it's simple. It's the marginal cost, right? Okay. So if this is the cost, then you look at how much your cost changed when you change the quantity demand, and that's going to be the price, okay? So you see that the marginal cost, this is called the co-energy. That's a function of the quantity or the velocity, all right? And the energy is the surface. They just happen to be the same in value. So it's no end to confusion will arise because of it, all right? But you got to keep these separate. So there are two types of value. The value that is inherent in the goods itself. This is what Adam Smith calls the value in use. Okay? And then the value that you can possibly get if you were to interact with a market, that it can be a momentum dump, a price dump. And that's the value in exchange. And the difference is what he would call the economic rent. This is something from Ricardo. And this is Adam Smith. This is also Adam Smith. But we don't use these terms much anymore. So we would say this is the market value, these are my costs, and we will call this the profit. Huh? So you just look at what's the market value of everything you're selling, you know. You subtract from that the cost you made, that is what it's worth to me. And the difference is just your profit. And the profit is also a rate, dollars per unit of time. In the end, this is all saying only simple things, okay? But what's difficult is to see how a definition of a want and a desire and then the realization of these and all of that through all the mechanics finally leads us to say something really, really fundamental, you know? Okay? Now, if I had said this before, Joris, you probably would have accepted this statement like this is obvious, and you wouldn't have all these problems. You know, now I see you holding your head, and you just, this is the right thing to do, because it's not so easy. Huh? What?
I have accepted this, I believe, 3 times now.
Yeah.
It's the fourth time it's passing my review for a long while now. So yeah, now all the questions start getting up, start boiling up.
That's the problem, right? So, and maybe the same questions are boiling up with what kinetic energy is, you know, and momentum is, okay? And it's just a hard subject, you know? But, and then sometimes the conclusions are just kind of a letdown because you go like, all of this, you know? But how would you have known that this would be a function of price? This would be, well, you would have been able to guess that probably. How would you have known this was that? How would you know how that relates to a change in price and dynamics, right? That's the huge accomplishment of Newton, right? So you have this idea of Leibniz that you did force. So you have all these ideas that you expend all this, and all these expenses, you know, and your booking and all this crap. But what does it say other than accounting like where you are? Financially, what does it say about the dynamics of this pricing, okay? Nobody was able to answer that. This connection, this is what makes it. So you can keep your accountancy going on, and you can book your profits, and you can do this, you know, but at the same time, you can do dynamics and calculate how these prices are moving and how quantity demanders are moving, you know? So the integration of the theory of demand with this kind of finance, that's the big break, okay? And that's hard, Joris. This is where you're going to break your head. Each individually is, you know, really easy to do, but combining it, that's the real problem. And so it is in mechanics. Everybody can kind of see what energy is. Then everybody kind of sees what this is, and then you know how motion is, and then how do they relate? You have no idea, right? But we'll talk about this further next week, okay? And see if we can torture you some more. All right? Huh? Okay. Thank you very much. And then, oh yeah, Thursday we'll have our mini symposium. I'll send